Hi there, and welcome to this Java course for absolute beginners. My name is Valentine, I'm a software developer, and while I use Java a lot, I don't consider myself an expert. For this reason, I've partnered up with Matt to bring this short course to you. Matt has tons of experience with Java and is also the kind of guy that knows how to explain this for beginners. Java generates less hype than other programming languages. Still, I can assure you that many organizations heavily rely on Java to build applications and to drive their test automation tools. Regardless if you want to build applications with Spring Boot or write API or end-to-end tests, you still need to know the basics. In this course, you will start writing Java code in a free IDE called Eclipse. Matt will take you over the installation process and all the basics like how to run and debug your programs. You will not be building anything fancy, but knowing the basics is a very important step. Make sure you check the video description for the course notes. We'll be putting there the most important steps you need to take, links to resources and any other updates just in case something has changed. If you ever get stuck, drop a message in the comment section below and we'll try our best to help you out. I will let Matt tell you more about what you will learn in this course.
Hi there, welcome to this course on getting started with the Java platform. My name is Matt Speake, I'm your instructor for the course, and in this course we're going to go through all of the kind of introductory things that you need to know about the Java platform to be able to get started. In other words, to start your kind of like developer career, if you like, with the Java platform. So a few things to say about this course. First off, this is a course for complete and absolute total beginners. So it doesn't matter if you've maybe had a little look at Java before, or if you know nothing about Java whatsoever. Don't worry about that. I take things completely from first principles. So you're not going to get stuck. You're not going to get into any kind of like issues where you're not sure how things work, because the course is going too quickly. Everything in this course is designed to be completely and totally for absolute beginners. I promise you it's absolute beginners. So you should be fine for this. So that's all well and good. But what's actually included in the course? What are you actually going to learn? So in general, you're going to learn three things you're going to get out of this course. And that's basically that we're going to get you set up with the tools that you need to be able to program in Java. So there's a certain set of tools that we need to get installed onto your system. So we're going to get you up and running with that. So you'll be able to get started and take it further. You'll have all the tools installed in your system by the end of the course. The second thing is that we're going to look into core concepts of Java. And when we say core concepts, we mean basically the absolute fundamentals that you need to know to be able to get started with the platform. So if you've heard terms like, for example, JVM, JDK, JRE, IDE, things like that, class files, bytecode, don't worry about all of that now. We're going to explain it all over the next few lessons, so that you're familiar with those core concepts. And finally, the third thing you're going to get out of this course is you're really going to get a feel for Java. So by the end of the course, you're going to know whether you want to take it further, how it kind of feels to you as a programming language, as a development environment. I think you'll take it further because it's a really fun and exciting programming environment to program in. But at the end of the course, you'll know yourself and you'll be able to make your own decision. So those are the three things you're going to get out of this course. Get you set up with the tools, get you set up with the core concepts, and you'll have a feel to know whether you want to take it further. Okay? So if all that sounds good to you, let's get started. So the first thing to know about Java is that Java is the world's #1 programming platform right now, today in 2021. And this is really quite exciting because it actually means that you're on the cusp of learning something extremely valuable, obviously with that marketable as well, but all of that as a package together, and I want you to realize this, takes you to the place right now where you're on the cusp of learning something really exciting and even potentially life-changing for you as well. Now, I don't say this lightly, but to be honest, if you want to have a career as a developer, as a software engineer, then pretty much Java is the best option for you at this particular time because it's been popular now for well over a decade. It doesn't look like it's going to change anytime soon with all of the different features that have been evolved, the marketplace share that it has, the kind of foothold that it has in the market. In other words, like all the different companies that are using it and that kind of thing. So this genuinely is a really, really, really exciting opportunity for you if you feel like you'd maybe want to go down that route of becoming a professional software engineer. Now, don't just take my word for it. We can look at a website. There's a website called, I'm not sure how you pronounce it, it's tiobe.com or tiobe.com. It stands for the importance of being earnest. And what it does is it tracks the popularity of programming languages by looking at the amount of web searches that people have done for that particular programming language and kind of plotting them in a graph, as we'll see. So if we just jump in now, I've got Chrome up here, a popular web browser. If I just jump into tiobe.com, here we can see we've got the website for it. And right over here on the right-hand side, you'll see this tiobe index. So if we click that, and we just scroll down, you'll see that there's a graph at the bottom of the page. So here we are. So this graph is basically charting the popularity of the most popular programming languages that there are today. And you can see it's giving, you've got C, Java, Python, C++, C#. These are different programming languages that you can choose to develop software in. The main thing that I want to point out here is that if we click on one of these, specifically click on the Java one, then from this you can clearly see by looking at the line graph that's highlighted, which is the one in black, which is the one for Java, you can clearly see that Java, pretty much in general, is ranked over and above any of the other languages. So while there might be some contenders for that kind of #1 spot, namely with JavaScript and Python, which you may have heard about, in spite of this, Java is still pretty much #1. And it looks like it's going to continue that way for quite some time. So just know that what you're actually learning in this course, when you're establishing the beginning of that journey as a Java software engineer, you're learning something that is very marketable and ultimately going to be very profitable for you as well for the foreseeable future. So I just wanted to point that out first of all. Now, before we start, I just have to give you a quick word of warning about Java. In Java, just like any form of technology or any form of programming, it's not specific to Java, this is any form of programming or anything to do with IT, there are always going to be lots of acronyms, so those are abbreviations for things. You're going to hear things like JDK, JVM, JRE, things like that. Don't worry about that, we're going to define those shortly. It's just a word of warning about that. And also, not only acronyms, we're going to have a lot of terminology as well. So we're going to hear terms like bytecode, source code, class file, compilation, those kinds of things. Again, when you first hear a word that sounds technical or you come across these abbreviations, it can seem kind of daunting because you don't know what the acronyms and terminology means. But don't worry about that. Don't be dissuaded. Don't be put off. I'm going to explain all of these in this course. I just want to give you that quick word of warning. So yeah, above all, don't panic. That's the key thing. Do not panic. All will be explained. Now let's start off with the key point about Java, which is this notion of platform independence. Java has this idea of something called WORA, W-O-R-A, which stands for Write Once, Run Anywhere. And this means that you can take a Java program and you can run it on multiple machines. Let's have a dive in now and see exactly what this means together. So let's start with my Mac. So I have a Mac Air, and let's suppose I develop a program on my Mac. And then I go to work and I think, do you know what? I could actually use this piece of software. I could use this code that I've written, this program. I could use it on my work laptop as well. But at work, I've got a Windows machine. And these are two completely separate types of machine. One's a Mac, one's Windows. Now to you, they might just be computers, and that's fair enough. They're just laptops or desktop machines. One's a Mac, one's Windows. But fundamentally, these are completely different machines. The key part of that is that, for example, if I use an application on a Mac, for example, Adobe Photoshop, then I can't use that exact same application on Windows. It's true that both Mac and Windows have a version of Photoshop, which they can both run, but that version is completely different. One has code for a Mac, the Mac program code if you like, and one has code for Windows, the Windows program code. And the actual code that each installation file will contain is completely and totally different. And the reason for that is that these are completely and totally different machines. We don't just have Macs and Windows-based machines, you can also have Linux-based machines. So for example, when we spoke about cloud computing earlier on, or if you look at large-scale websites like Amazon, the e-commerce site for example, you'll find that what powers those websites are hundreds, if not thousands, of these so-called server machines. That just means a computer without a screen pretty much, just super fast hardware or electronics inside to be able to power these huge e-commerce applications. You also have those as well. And again, Linux is a completely different type of machine than a Mac or than a Windows machine. So given that we've said that if you have an application or a program on one machine, like a Mac, and it's not possible to run it on another machine like Windows, how does Java do this then? Well, let's take a look inside and see what happens. So let's take a look at actually what's inside the Windows machine. So inside that machine, first off, we have an operating system. And the operating system is a foundational computer program, if you like, which tells the computer how to run. And what I mean by that is that if you didn't have an operating system on, for example, a laptop or a desktop machine, then you wouldn't be able to load any programs onto it. You wouldn't be able to access the internet. You wouldn't even be able to switch it on and have it do anything meaningful. You'd just switch it on and nothing would happen. And that's because all computers need an operating system installed on them, which is kind of like the super program of the computer, if you like, which tells the computer how to run. So for example, it tells the computer how to access files, how to access the network, how to display stuff to the user, how to print to printers, that kind of thing. That's what an operating system does. We have three different types of operating systems. We have operating systems for Windows, Mac, and Linux, which is why we started off with those three machines initially. So once you have an operating system installed on your machine, that means you can actually start to run other programs on it. So for example, on my Windows machine at work, I can run Microsoft Word, edit some outlines for a course, for example. I can also have Google Chrome running as well, do some web browsing. Maybe I have Outlook as well to be able to access email. And I can do all of those three things, execute those three programs at the same time, thanks to this operating system that we have. And also underneath the operating system, by the way, is the microprocessor. This is the actual chip inside the computer itself. I've kind of grayed that box out because we don't really need to know anything about the microprocessor, apart from the fact that having an operating system means that the three programs at the top, Microsoft Word, Google Chrome, and Outlook, they don't need to concern themselves with the different types of microprocessors. So in this way, the operating system kind of shields those programs away from the much deeper complexity of the actual chip inside the computer itself. But in addition to these programs, if we're looking at Java, we can also install another program, and that's known as the Java Virtual Machine. Now, the Java Virtual Machine is really where all the magic happens, because it's this JVM, the Java Virtual Machine, it's the first acronym there, that allows us to run different Java applications. So looking at the JVM, once you have a JVM installed on a given machine, that means that you can run first Java application on it, you can run your other Java application on it, and again, another Java application on it. So the JVM gives us a facility then to be able to run Java programs. That's the key point here. Now going back to these three computers we saw before, you can have different operating systems on them. So if you have a Windows machine, you might have Windows 10 on there, Windows 8, Windows Vista, Windows XP. Those are different versions of the Windows operating system. If you're on a Mac, like I am, you'll have Mac OS 10. And on Linux servers, you're going to have something like Ubuntu, SUSE Linux, Red Hat, or Fedora. The key point here, though, is that these three machines each have installed on them different operating systems. However, because each of these machines, or specifically each operating system, has a JVM available for it, that's the Java Virtual Machine special application we've just seen. So there's a JVM for Windows, a JVM for Mac, a JVM for Linux. Because of this, that means that the Java program that you write can then run on each one of these machines. So this means you can write your Java application on a Mac, then run it on Windows, or you can write the Java application in Linux and run it on the other two machines, Windows and Mac. It really doesn't matter. And that's really the power of this so-called WARA, or this write once, run anywhere. The fact that Java gives you the ability to be able to do that. So you write the application once in Java, and then it can run anywhere you choose to put it. Now, there are a few other acronyms as well, which we'll just quickly go over. We'll get to see these a bit later on too. The first one is the JRE. This is the Java Runtime Environment. And this is basically effectively the package that contains that JVM. So when we saw the JVM just now, which was sitting on Windows, Linux, and Mac, that JVM actually comes as part of the JRE, the Java Runtime Environment. And that's a key there as well, it's the Java Runtime Environment, because you're running programs. So because it's the Java Runtime Environment, that's where you'd expect to find this JVM, because the JVM's responsibility is to run those Java programs. We also have the JVM, which we've seen, the Java Virtual Machine. Yep, that's the thing that runs those programs we've seen. And we also have bytecode as well. So bytecode pretty much is what the JVM runs itself. It's kind of like the language that the Java program is turned into, which the JVM can then understand. We'll see this in a little bit later when we look at compilation. But what I mean here is that the JVM as a program, which runs Java programs, needs to take an input. It takes an input file. That input file contains the programming commands to tell the program what to do, but the actual program code itself, and that program code, that is bytecode, packaged in so-called class files, which we'll see a little bit later on too. So who creates the bytecode? Well, what creates the bytecode is a thing called the compiler. So just to recap, we've got the JVM, which runs the Java application. The Java application is a file called a class file. That class file contains bytecode, and the thing that produces the bytecode is a thing called a compiler. So the compiler's job is to basically take your Java program and convert it effectively into instructions that the JVM can understand. And it does this by taking the program you write in the Java programming language, and that's known as source code. So you write source code, the compiler takes that source code written in the Java programming language, converts it into bytecode in a so-called class file, and then the class file displays as input to the Java Virtual Machine, and the Java Virtual Machine executes each instruction inside that class file, the bytecode, to actually do what you've programmed it to do. We're going to move a bit further, and we're going to see how we can actually install the JDK itself onto our own machines. So in order to install the JDK, we need to do 4 different things, really. First off, we need to work out which version of the JDK we need to install. So that means basically we need to download the right JDK. So if it's the JDK for Windows, download the Windows one. If it's a JDK for Mac, download the Mac one. But even amongst the individual operating system, there might still be some choices, which we'll see. Next, we need to download and run the installer. This is a really quick process to do. It's literally just kind of double clicking. So that'd be nice, simple and straightforward. Next, we need to set a thing called an environment variable, which is going to be called Java_home. Now, environment variables, it might seem it's getting very technical now. It's really not. It's basically just a way of letting other tools which work with Java itself, it's a way of letting them know where you've installed the JDK to. And we do that through creating this thing called an environment variable, which is very simple to do and straightforward, as we'll see. But it just basically makes that piece of knowledge, knowing where the JDK is installed, just exposes it so that anybody, or any other applications rather, which are running on that machine, can take a look at the environment variable, access the path or location of where we installed the JDK to. And finally, of course, we need to test that it actually works. So just go down here into the search box, and we're just going to type in Internet Explorer. Just the first few letters will do, as you can see. So here we've got Internet Explorer, so we'll just click this. And if we just type in here, Java JDK download, and you can see that it's showing us here the first link, the primary link, is the one that goes to the Oracle website. And this is basically for all of the downloads. So all of the different versions that you have with Java, this is the page that you can get them from. But we want to have a specific version. We want to go for Java 8. And that's because it's a lot easier for beginners to work with Java 8 than it is to work with the latest and greatest version, which is Java 15. So if we click on Java 8 JDK, accept cookies. And so here we are on the Java 8 JDK download page. So if we just scroll down, you'll see here that the version we're going to download is this 8U281, which is basically the latest version of the Java 8 version of the JDK, which is the one we're after. And then if we go a bit further down, we can see we've got Linux here, we've got macOS, Solaris, and right at the bottom, we've got these two options here for Windows. Now at this point, we need to know whether we have 32-bit version of Windows or a 64-bit version of Windows. So there are two different versions of Windows that you can have, 32-bit and 64-bit. And these are denoted by x86, means 32-bit, and x64 means 64-bit. You wouldn't necessarily expect that. And this is actually a reference to the underlying microprocessor. But just know that the 64-bit version one has 64 in it, and the 32-bit one doesn't. So we've checked already on this particular version of Windows, and we know that it's a 64-bit version that we need. Because if you remember, that's the x64 that we saw before. So let's download the 64-bit version now. So if you just click on this exe file, and we'll just accept the license agreement, clicking that checkbox, and then just click this download button here. And so, unfortunately, when you download the JDK, you have to have an account with Oracle. It's free to sign up, so if you don't have an account, you can use this create account button down there. But I already have an account, so I'll just put my details in. And then just hit sign in. Then you can see here now, it says do we want to save or run. So I like to save it to the downloads folder, and then I can run it from there afterwards. I'm not bothered about saving the password either, so I'll just click not for this site. So now you can see it's downloading. It doesn't take very long to download. It's not that big, to be honest. And also I've got a pretty fast internet connection as well. Almost there. Runs a security scan. And it says it's completed, which is good. So then if we hit this view downloads, we can see here that it's actually in this downloads folder. We also hit this button here. It'll open up the downloads folder itself in Explorer. So I prefer to run it from there. So if we just kill this browser, and just this one too, then we want to run it from here. So you want to right click and you want to do run as administrator. And that's important because it needs to make some entries into the Windows registry, which needs administrator permissions. So if we just click yes to this so that you can make changes to the system. Now we're just going to click next here. And then we go to the next screen. And on this screen, we can see the items that it's going to install. So it's going to install the development tools, also the source code of the actual JDK itself. Plus as well, we've got the JRE, which will also install. So just accept the defaults here. You could customize the folders if you wanted to, but that's fine. We're just going to accept the defaults for now. That's okay. Just click next. And then we can see it's just installing. It's pretty quick, to be honest. Copying the new files across over. At this point here, it's offering to install the JRE for us as well. So you can just click next to that also. And it's just going to run through that part of the installation procedure as well. Again, it's pretty quick. You can see here that Java's been going for 25 years as well. So it's a really stable and rich platform to work on, which is why it's so popular. At this point, it's been installed. So now at this point, if we go into the C directory, which is under this PC. And we look inside this program files directory, under Java. Then we can see here now we've got two folders, JDK and JRE, for version 1.8. So this is basically the JDK, the Java Development Kit, and this is the JRE, the Java Runtime Environment that we've spoken about before. Just quickly, while we're on the topic, let's just have a quick look inside. Inside the JDK, you'll find a bin subdirectory. Subdirectory means a directory inside a directory, and these are all of the tools, if you like, which you have access to as a Java developer to help you write Java programs. But the main ones you're interested in are Java C, which is the Java compiler we've seen, and Java itself, which is the Java virtual machine. Now, the next step we need to do is we need to, if we just go back out to that folder above, we need to basically put this folder here, which is the folder where we've installed the JDK to, we need to put this in this so-called environment variable. So let's see how we can do this now. So first of all, if I just double click this, then I click into the address bar here, just go over here and just right click and then click copy. So what I've done actually here is I've just basically put the contents of this, so the directory that's highlighted, into the clipboard, because I'm going to use it later. I can just cancel this out now, and then I can go into this one here, this PC, into properties, which is actually an easier way of being able to set this environment variable. And then if we go into advanced system settings, you can see here, you click on that, and then click into environment variables. Now, what we're seeing here, this is basically the set of environment variables which are configured for this particular system. So the concept of an environment variable isn't just specific to Java or even specific to Windows. It's a concept which is available in all operating systems, and it just basically provides a little place in memory where programs can look in to get a piece of data they need to share. In the case of the Java tools, that's the JDK installation path, and that's what we're going to set now, but there are other ones too. The most important one being path itself, which is the one you can see here, which we'll come to in a second. But first of all, let's create our Java_home. So if I click new here, then go Java_home. If I press tab, that gets me into the text box below. Now if I just do Control V, paste it, then you can see it's here now. Now also, if we just put that in quotation marks, the reason being is that Windows is a bit funny if you have spaces in a path, path meaning the actual descriptor of where the folder is, which is this thing we're looking at here, it's a path. You can see here we've got this space between program and files. So just to protect that, we basically put a quotation mark here and a quotation mark there, and then that kind of like packages it all up, if you will. So if we just click OK now, so now we've got Java home set. The final thing to do is to double click on the path variable to change that. And we're going to add a new entry here, which is Java_home with these percentage signs at either side. And that basically means resolve this to the actual value. So Java_home is the variable, that's the name of the piece of memory which holds that data. But to get what's actually in that piece of memory, we can put percentage signs around it. It's known as dereferencing that variable. To get the actual value out, and then put \bin and enter. And the reason for that is because, remember, we've just had a look in the JDK directory itself, and we then had a look in the bin subdirectory and we could see all those tools. Well, by putting this in here, adding it to the path, this is going to allow Windows to locate those Java tools for us. So basically, whenever you enter a command in a DOS prompt, which is something we'll see in a second, one of those scary black windows, which isn't that scary in fact, but it might appear so at first, but it is really not. Whenever you enter a command in there, what actually happens is Windows goes through each one of these folders in turn to look inside that folder to see if that command exists in that folder. And when it finds whatever the command exists, then it will execute it. So we're just going to move this up. This a few times, and that means that the first place that we're telling Windows to look is definitely going to be in like this Java home directory, Java home bin directory rather. And the reason for that is because, unfortunately, Windows actually comes with a JRE to be able to execute Java in the browser, and that's actually stored in this path here. And by putting this Java_home bin before that, it means that we're going to get our version of Java, which is part of the JDK, which we've just downloaded. So if we click OK to this, and OK to this, and let's close some of these windows, we're going to go into the command prompt, or this DOS prompt. If you type CMD, you'll see here we have this command prompt. Click on that. And now we're in a thing called the DOS prompt, or as it's now known, the command prompt. And it's called that because it's prompting you, prompting meaning to ask. It's asking by virtue of the fact this thing's flashing, this cursor's flashing here. It's asking you for a command. It's a command prompt. Makes sense, yeah? So if we type setj, which is a command, and hit enter, this is going to show us the environment variables which have been set, which start with the letter J. And you can see here we've got our Java_home environment variable that we set. If we were to do set P, then we'd see all of the variables which start with a P. And the first one we can see is path. And now we can see here that we've got the Java home environment variable we saw before. It was being dereferenced by those percentage signs, remember, with a /bin after it. That means the subdirectory inside there. If we now type in Java C for the Java compiler and do version, then we should get a message back which says it's the 1.8 Java compiler. And the reason we're doing version is just it's a nice, quick and simple way just to verify that a given command has been installed properly, which in this case is Java C. And we can do the same thing for Java as well, which is the JVM. That means that we've got the JDK set up correctly. And just to double check that as well, we just check the Java version. And similarly, we also have the same version here. So these two versions match now, 180.281, 180.281, which is fantastic. So here we've got the Java compiler, and we've got the Java virtual machine. Don't forget, if we hadn't have put that entry to be first in the list, then we wouldn't have seen that version here, because it would have been picking up the Java version from this one here instead. Anyway, at this stage, we're all set up, and we can actually start to develop Java applications on this Windows machine. We're going to take a look at the IDE. That's an integrated development environment. That's basically a tool that you can use to write, compile, and run your Java programs, which no programmer will ever be without. So let's jump in. Now, there are two different IDEs on the market currently. When I say on the market, you don't have to buy them or anything, but I just mean those that are available to you in general to download. Now, both of these are free, or at least have versions that are free, and we'll just have a look at both of them now and compare them. So the first one is Eclipse. So Eclipse has been around for a really long time. It's from the Eclipse Foundation, and it's a really good IDE to start off with. The other one we've got as well is IntelliJ IDEA. Now, IntelliJ IDEA actually has two different versions that you can get. It's got a community edition, which is the free version, and it's also got another edition called the Ultimate Edition. And that's a paid product, which typically you'll find in corporate organizations. So in other words, in corporates where you have a professional Java development team, if they're willing to spend the money on the IDE and on the developers, typically you'll find they're using IntelliJ IDEA. Now, the difference between these two are that Eclipse is really easy to use. It's great for beginners. It's got various features which make it more suitable for beginners, in my opinion. Like, for example, when you're programming, it will actually highlight errors as you go along, by underlining them in red, which we'll see in a second. And it gives you very clear error messages, which kind of imply or kind of tell you pretty much how you should fix your code. So it's great for beginners, and it's very easy to use as well. For professional developers, it can feel a little clunky at times. And so a lot of professional developers tend to prefer IntelliJ IDEA. And again, that's for more advanced users. It's got much more power behind it because it can also be a commercial product. With their Ultimate Edition, they've really made this product into something which you'd expect a proper Java developer power user to be able to get their money's worth with. However, that said, IntelliJ IDEA, it kind of does things behind the scenes, which you've got to be careful about if you're not a professional developer and if you don't know what you're doing. So it can kind of trip you up. So it's definitely for advanced users. But Eclipse is definitely the thing to start off with, and we'll see how to install that shortly. Let's jump in now and install Eclipse, which is the best IDE you can use if you're a Java beginner. Let's jump in. So if we go to Internet Explorer again, this time if we type in Eclipse, here we can see we're at the website for eclipse.org. It's the first thing that pops up, and we're just going to download Eclipse IDE. So just hit the download button here. And again, you've got a choice of which operating system you're going to use. We're on 64-bit Windows. So here we can see this x86 64, which means it's compatible, by the way, for both 32-bit and 64-bit versions of Windows. That's fine. Click that. And then we'll just hit download. Again, same kind of thing. We're going to save it. Doesn't take too long to download as well. Now we can see it's completed. So if we just go to open folder, we can close this now. We can see here we've got the Eclipse installation. Now, if we double click this, because we set that Java_home environment variable before, Eclipse now knows where to pick Java up from and how to run. So you've got different options here. We're going to choose this one. And we just install, accept the agreements. And now it's actually downloading that particular version of the Eclipse IDE onto your local machine. And it might take a while to download, but that's fine. You can see now it's downloaded. So if we just do launch, notice as well it's also created a shortcut there on the desktop as well. The first time it launches, it might take a little bit longer. That's fine. We'll just accept this as the default for now. Launch again. And now here we are. We're inside Eclipse. Just close that. So this is the Eclipse welcome screen, and you can just hide this and close this panel here. And then at this point, we're all set up. We've installed Eclipse, the IDE for Java, and we're all ready to start creating a new Java project. So let's have a look now and explore actually what features an IDE gives us. So the first thing an IDE does is it provides you the ability to actually type in your programs. So just like, for example, you might use a word processor like Microsoft Word to type up documents or reports for work, or you might use a spreadsheet like Excel to do your accounts or manage your home expenses. Just like that, as programmers, we use an IDE to type in our Java programs. And this makes things much easier, as you'll see, because of some key features which an IDE provides. The main ones of these are syntax highlighting, showing you the errors you've made, and suggesting improvements to your code as you go along. Let's take a look. So, by the way, I'm on a Mac for this, but don't worry though, because actually as it happens, Eclipse and IntelliJ IDEA, they're both applications which are programmed in Java. And so because of this, it means that they're pretty much the same to use on both platforms. So you shouldn't have any difficulty in understanding me showing you this on Eclipse on a Mac. If I jump in now, and I just click this Eclipse. So we'll just accept this as the default. That's fine, just do launch. So if we just double click this, maximize it, and get rid of this screen. And here we can see we're in Eclipse. And here we can see we're actually in the so-called Eclipse workbench. So you'll see here that in the main pane, we don't have any program code yet. That's because we don't have a program. Specifically, we don't have a project, in fact, which is where we actually put our program code. In order to write a program, you need to have a project. So that's the first thing we're going to do. So let's jump in and create a project together. So there are different types of projects you can see over here. I'm just going to go into this one and create the simplest possible type of project, Java project. If I go down to next, project name, we'll just call it My App. We can accept the defaults on here. So just go down to finish. And it's going to ask us if we want to open up an associated perspective. This is basically a layout of the windows, which defines pretty much what tools you want to see and where you want to have them positioned. So I'll just do remember my decision and then do open perspective. And now we're in this so-called Java perspective, which means we can actually start doing our programming. So if we go over to here into Package Explorer and double click this, this actually shows you the project itself. So the project so far just has two things associated with it. It has source folder, which is where we're going to put our program code, and it has this JRE system library. This is basically saying which version of Java you're going to use. So I want to create a class, which is going to be the main program. So I right click here and I go into new, and I could just go straight for new class. I could do that, but instead what I'm going to do is I'm going to create a package first. And a package is basically kind of like a well-named folder in which you can group different source files. That's not too important to understand now, but in general with Java, it is something that you need to do where you basically place classes into packages. Just keeps everything nice and organized. So I'm going to give a package name of com.javaeasily.demos. I'll do for now. And then I'm just going to hit enter. I don't have to use the mouse to click this finish button. If it's already highlighted blue like this, I can just hit enter and it saves me from having to move the mouse over there. So enter just picks out the default button that's currently highlighted, effectively clicks it for you. And by the way as well, packages in general, they follow what's known as the reverse domain convention. That basically means that you take the domain name of the company that you work for. In my case, it's javaeasily.com, and then you reverse that. That will give com.javaeasily. And then after that, you can put whatever you like, which makes sense to your organization, just to be able to group the different classes that you write. So here, this explains com.javaeasily.demos. So let's just take a look at actually what's inside a Java application then. In other words, what are the components we'd expect to find inside a Java program itself? So first up, we have a class definition. And this basically is the main unit of code that you create in Java. So when you write a Java program, pretty much you're writing these classes, which can then be assembled into objects. And then how the actual program works is that these objects can have methods invoked on them. A method is like a chunk of behavior which you want the object to do. That method typically will cause an interaction with another object, or it'll cause the object itself to somehow change its state. In other words, to change the data that's actually inside the object. So first off, yeah, we have a class. And how you declare a class in Java is that you have to use this kind of syntax here. So when we say syntax, we mean basically the sequence of words you've got to use, whether you have to use any special symbols, like for example, you can see here we've got this kind of like curly bracket thing. This is known as a curly brace. So you've got a left brace there at the top after the word my app, and you've got a right curly brace at the bottom, you can see. That's basically the syntax. It's a combination of words and symbols used to define the class of the Java compiler. Because don't forget as well, it's the Java compiler, that Java C program we saw, that's going to be responsible for taking the source code that you write, taking the Java code that you write, and then producing a bytecode file out of it. And because of this, it needs to follow a very well-defined format of how you present things. In other words, you need to speak its language. You need to speak the language of the compiler. And that's basically what you're doing when you're programming in Java. You're speaking the language that the compiler understands. Writing your program in Java, so it can then be compiled down into bytecode and run on the JVM. So here we can see we're creating a class. The class's name, all classes have a name, and the name of this class is myApp. So you can call a class whatever you like to call it. It's entirely up to you. And typically you'll call a class, give it a name that is based on the actual thing that you're modeling. And in this case, a name like myApp, for example, would expect maybe this is like a class which would be the kind of starter class, if you like, which starts off your Java program. So in other words, it's kind of like, think of it as like the main class, or the top level class, if you like. After all Java programs need to start somewhere, and they start with a method which contains the behavior to start the application, and that method needs to be defined ultimately inside a class. So we can imagine that this class here, myApp, is a class which effectively contains your application. Okay. Now how we actually define a class myApp is we use the class's name, which is myApp, as you can see there, and we can see it's got a capital M and a capital A. That's because in general with Java, when you're defining class names, you capitalize the words that make up the name of the class. That's why it's capital M and capital A. And immediately before this, we've got a word which is class. And that's because in Java, when you're defining something, you have to tell the compiler what it is you're defining. So you're defining a method, or a class, or a variable, whatever else it might be. We'll come across these things a little bit later on, but for now just know that to create this class, you must at least have word class, then followed by the name of the class. And then of course, inside the class itself, you need to actually give the code which you want to go inside the class. So in other words, you need to give the methods which define the behavior of the class. You need to define those inside the class, and you also need to define as well the data that it's going to hold. So a class in general in Java, it holds methods, which will tell objects what you want them to do, and it holds data, which will tell objects data, or the state if you like, which you want them to hold. And you need to wrap all of those inside these curly braces, which you can see here. So a class declaration in Java at least needs to have class, then the class name, then an opening curly brace, then the code you actually want to put in the class, and a closing curly brace. Now you'll also see this word at the front, which is public, and that's because in general, most things that you declare in Java can have what's known as a visibility modifier. And that's just a fancy way of saying how visible that thing, in this case a class, is going to be to other items or other things inside your program. And with this word here, public, it means that basically everything inside the scope of the program will be able to see the class myApp. We'll see this a bit further down the line when we code a quick class up in an IDE, but yeah, that's basically how you declare classes inside Java. So now if I just right click in here, now I can create the class. I go to new class, and we can see here it's going to create it in the source folder. It's going to create it in this package here that we've just created. Now I just have to give the name of the class. So I'll call it myApp. And also there's some extra options here which we don't really care about. Apart from this one over here, we tick this, it's also going to create that standard main method, which we said before kicks off the Java program. So we'll just do that and click finish. Now we can see we've got our first class, myApp, where we can put our program code, and we put it inside the main method. And at this point, this is a fully working program. It doesn't do anything because we haven't actually got an implementation. We haven't got anything, rather we haven't given any instructions inside here. What is syntax highlighting? This is one of the things that the IDE does for you. So what is syntax highlighting? Okay, so here's a chunk of code. It's a very simple piece of code in Java. It might look complicated, it's really not. And it basically defines class myApp, which has one method in it, which is the main method, one and only method, which is going to do something. And what it does is it's going to print out the message, hello world. Now, if you see this program in an IDE, it would actually have syntax highlighting, and that looks like this. So basically here you can see that it's colored in some words, it's given some color to the words, and those words which appear to be in, I guess, kind of like a maroon or a dark red, maybe purple, depending on how your eyes are. But anyway, these words, like public, class, public static void, those are basically colored that way to signify that they're keywords. They're reserved words by the Java language. So the use of this, for example, is if you maybe, for example, misspell public and miss out the I, then it wouldn't color code that into a maroon color, and you'd also have kind of a squiggly red underline as well, which will tell you that it's wrong. But coloring words in this way, coloring the text in this way, it just gives you that extra kind of quick visual guide to the meaning or the so-called semantics of that word or that keyword. Now you can see we've got other stuff which is still in black. So typically these are going to either be class names, methods, or types. So here we can see myApp is the class name, main is the method name, and the string array there, string with the 2 square brackets, that's a type. We'll see again the actual variable name, which of the thing we're passing in, these args value. A bit difficult to see, but that's actually in a different color again. That's how you can tell or differentiate inside that method between those two curly braces. You can see immediately whether you'd be working on a variable, which is passed into the method, against a variable which is outside the method, for example. You'll also see as well on the third line in where we've got the system.out.print line, we can see we've got the out is italicized, so it's in italics and it's also in blue. That denotes that that's a static data member, which is a bit advanced now, but it's just another way they can visually give you a bit of help. And inside you can see we've got the string which we're passing into system.out.println, which is the command that prints something to the screen. We can see we're passing in that string in quotes, and we can see it's color-coded that a nice bright blue for us. That's how we can immediately tell where the strings are in the method as well. That might not seem that useful, but the more complex your programs become, you really get to be able to kind of see the code better with these kind of features. But you won't tend to notice it too much when you start out though. So how does it show errors then? I mean, that's probably the most important thing you care about if you're a beginner. So here's an example. So this is Eclipse. And here we can see we've got the main method. We've got this application we saw before. And here we've got a class. So it says public class myapp. And you can see it's got a red underline underneath myapp. And there's a red kind of circle to the left of that, the line numbers. And if you look beneath there, you'll also see the same red circle with an X in it. And it says Java problems, 1 item. And it says syntax error on token myapp. It says a left curly brace expected after this token. So you can see here, it's actually telling you what to do. It's telling you that after myapp, which is the word it's underlined in red, it's expecting that you're going to put this opening curly brace. And in fact, the minute you put that opening curly brace, the red X would go, the red underline would go, and the problems, which you see there in this Java problems section, that list, that would also go as well and be clear. So that's one way it can show you that things are not quite right. And you'll see red X's everywhere contextually where that is. So if you see on the left-hand side, for example, this is basically the project structure. You can see at the deepest level, you've got this myapp.java. And then above there, you've got app, which is the package that's in. The package is just a folder for a class inside Java. And then above there, you've got source main Java, which is the folder which contains the actual Java code itself. And above there, you've got app, which is the name of the actual project. And again, as soon as you fix it, those will go. Next up, we have these method declarations. So as we've said, in Java, classes contain methods. And a method basically is the program code, or rather it contains the program code of something you want to have happen. So here, for example, we've got a method called greet. Again, methods have names just like classes do. And again, we can see we've got the opening curly brace and the closing curly brace. So as you might imagine, inside these two things, you have the actual code that you want to execute whenever this greet method is called. In other words, the thing you want it to actually do, which is also known as the implementation of the method. And you'll see also again that at the front there, we've got this keyword again called public. So by the way as well, we have these things called keywords. So keywords are basically special words that you use in Java, which signify something special to the Java compiler. As we've said before, we've got public, that's a keyword. And public means that any other items in the program can access this particular thing, which in this case is a method. That means that if I have 10, 20 different classes inside my Java program, all of those classes will be able to see this greet method. That's one keyword. Void is another keyword, which we'll get to in a second. And we have class as well, which we've just seen before, which is the keyword used to declare a class. So I come into this void and the brackets, which you can see here. So after greet, after the name of the method, which is greet, we've got these opening and closing brackets called parentheses. And what you normally find inside these parentheses are you find the input parameters. So in other words, the inputs that this method can take. So a method in general, you want it to do something, and in order for it to do something, sometimes it might need to take, actually more often than not, it might need to take some specific input, some specific parameters we call them. So you'd place them inside these parentheses. Now if you just see parentheses on their own with nothing in them, then that actually means, quite logically, there are no inputs to this particular method. So here this method called greet, it doesn't take any inputs. So in other words, it doesn't need to have any values passed to it to be able to do its job. And the reason is because, for example, you can imagine it would just display hello world on the screen. And if it just displays hello world on the screen, it doesn't need to have an input. Conversely, if you wanted it to take an input, you could, for example, pass in a so-called string, which is a piece of character information, in other words, a word pretty much. And that string might be called name. And then you could say hello, and then the person's name. So you could use that so-called variable to be able to access the value that's passed to this method. We'll get to how we call methods, also known as how we invoke methods, a little bit later on when we get into the demo of how we can code some Java. But for now, just know that the parentheses enable you to pass to the method the inputs of that method, so the parameters that it takes. Now, if you pass things in, obviously there's a chance that you might want to pass things back out. And you can pass something back out by the word which goes before the name of the method. And that's that special void word we see here. So a void in this case is a special word, special keyword, which actually means don't return anything. So again, in the case of the greet method, which is just going to display hello on the screen, it doesn't need to return anything. It doesn't need to pass anything back to another method that might have called it, because methods can call other methods. That's how Java programs work to get the job of the program done. And in this particular case, because it's just printing a single thing, which we'll just define inside the method itself, which is this hello world, a couple of words, it doesn't need to return anything to anybody else. So then you'd use this keyword void. Now, if you wanted to return something else, for example, you wanted to return the greeting itself, then you could replace void with the actual so-called return type. That's basically the type of the thing that you're returning. You could say public string greet, and that would mean that this method returns a string, character data we saw before. So a string of alphabetical characters, basically. Or maybe you want it to return something else. You could return an int, for example, which stands for integer. That could be just a number you're returning. You might return a date, if you're doing some kind of logic to manipulate a date on the calendar, that kind of thing. Or you can return an object as well. So you can choose to return whatever you want, basically. And also, similarly, with inputs, you can also choose to pass in whatever you want. So again, objects, ints, those are numbers, strings, that kind of thing. Whatever you want to pass in, that's fine. You just separate them with commas. That's how method declarations work. So let's just plug in a line now just to print out our message. So to do this, we use the system class, which is part of JDK. And you'll see here that it's in the java.lang package. So that's one thing to know about Java, that any classes which are in the java.lang package, they get what's known as imported automatically for you, which means that you don't have to explicitly declare that you want to bring some class in to use it. Now, we haven't looked at imports, but basically if you want to use class from another library, typically what you'll do is, between the package statement at the top on line 1 and the class declaration on line 3, you'll use an import statement. And the import statement will be something like, for example, import java.util.list. For example, if you wanted to reference a list from the java.util package. Now, Java comes with a whole heap of different classes, which are inside various packages as part of the JDK, and you can have all of those at your disposal as well. But for now, just know that we've got the java.lang package, which has effectively been auto-imported for us. Anyway, so then I do system dot, and you can see here this is the compiler giving us helpful suggestions. So if I look in here, if I scroll up, you can see that it's not just one method or field it's given us a whole heap of them, a whole different array of them. So these are all the different methods or fields, these variables inside the class, that I could actually access now. So for example, we're going to do this one here, which is out. So I could either type out like that, and as you can see, as I typed each character, if you just back up a little bit, as I type each character, so I type the O first, you can see there that it's actually matching and filtering the list based on that specific letter. I do U next. Now you can see it's got two options it can suggest for me. I want this one. Also as well, another really nice thing in Eclipse, you'll see on the right hand side there of the method and field suggestions, they've got this kind of like documentation panel. And this is actually showing you the so-called Java doc, that's the Java documentation, for this particular field on the system class. So it's really nice that you get this kind of help, specifically when you're starting out as well. So you can then go over, for example, just have a read of it. You can scroll up and see what it's telling you. You can see they're saying there's some other methods that you could also choose to look at as well if you wanted to. We're not going to look at this in detail now, but just know that it's there to help you. And it's another one of these nice aspects of Eclipse that you have, which again makes Eclipse, in my opinion, the best IDE for beginners to start out with. That said, if I hit enter, now I've got this system.out reference, which is a reference to the print stream, which enables us to be able to write a message to the display. Now if I press another dot here, you can see we've got the same kind of thing again. Only this time, instead of it showing us, like it did before, methods or fields which were available on the system class, now of course, we're not accessing the system class anymore. Now we're accessing the print stream, because out, which is a field inside the system class, the actual type of that is a print stream. So that's how it works in Java pretty much. Whenever you have a dot, it's the thing immediately to the left which is being referenced. And again, when you press the dot, you can either access fields on the class or object, or methods on the class or object. Another method I want is called printline. So if I start typing printLn, you can see here we have a whole heap of methods which all appear to have the same name. And that's because they're the same method, but in Java you can specify a method multiple times with each method declaration accepting different types of input. And that makes the method very flexible. So for example here you can see we can choose to pass in, I use my arrow keys, an integer. That's the type for those whole numbers we saw. So numbers like 3, 17, 4072, that kind of thing. Or we could pass in a string. So that's where we have a message which is in quotation marks. So yeah, that's a very flexible feature of Java, and it's not as method overloading. If I now press enter, then you can see it's automatically selected that particular method for me. It's also put the parentheses round as well, And now it's also saying, okay, well, give me a string, which you can see there above. If I just put quotation mark, hello world, the quotation mark, and at this point, you can see that we've no longer got any red underlined squiggly underlines, nor do we have any of those red crosses in the circles, and that's because now this particular class is valid Java code. In other words, it can be compiled down to bytecode and then executed on a JVM. If I move this cursor away, you can see as soon as I moved it to the right, by the way, I'm using the arrow keys to do this, so your left arrow moves you one way, right arrow moves you the other way. So as soon as I moved it to the right, because we were outside of those parentheses, then Eclipse noticed that there's no point in giving us that little helpful tip which told us what it was expecting, which was a string. The other thing an IDE allows you to do is to actually compile your code. So at this point, we've got a valid program. Now, if I just save it, because we've got this star here, which means we haven't saved it, so I'd do Command S on a Mac, Control S on Windows, just save that, and then if I right-click on here, on the class itself, and do Run as Java Application, and then we'll see here we've got this new tab which has popped up called Console. It says that the program's finished, that's what terminated means. And you'll see underneath, we've got a message, that string that we passed to system.out.println, which said hello world. So you can see here a few things. Number one, it's allowing us to type in the program code. And with that, it's giving us syntax highlighting, showing us when we make errors, and it's providing helpful suggestions. Number two, because it ran the program, that means it must have compiled the program down to bytecode. So it must have invoked the Java-C compiler somewhere along the line, which we'll see in a second. And finally, number three, it's actually running the program for us as well, which means it's passing that compiled bytecode to the JVM. And we can see here, in fact, this is the actual command that it used to do that when it launched the JVM. Now, just to show you as well, we actually do have a class file which was generated. That's the bytecode, don't forget. If we go up to Window and go to a new view, we go down to Navigator, then you can see here, this is actually showing us all of the files which are in the project. So this panel here, this pane here, is just showing us basically the items that are relevant to our source code. It's just purely focused on showing us the relevant things. It's actually shielding things from us that we don't necessarily need to see on a day-to-day basis, which is kind of good, because then you can just focus on exactly what you need to focus on, which is the actual code and making that work. But you'll see we don't have, for example, the myapp.class file, which we'd expect. It is there, it's just in a separate subdirectory. So if we go down to the Navigator view here, you'll see that this is the actual real project structure with all of the files. And you'll notice that inside our source folder, we've got source, com, Java easily demos, myapp.java. By the way, that's one thing to bear in mind as well, that the package that you place a class into actually gets turned into a directory structure like this. So you can see this is like com.javaeasily.demos, which corresponds to com.javaeasily.demos up there. Anyway, that's where the source file was. And similarly, if we go into the bin subdirectory, we'll see the same structure. So we'll see com.javaeasily.demos corresponding to com.javaeasily.demos, because Java classes in a specific package compile down to class files which are in the same package, so therefore it has the same folder structure. And inside there you can see we've got myapp.class, which corresponds to myapp.java here. So myapp.class, myapp.java. So if I close these off, and this one too, and you'll see there are also some other files and folders there as well. We've got .project, .classpath, and .settings. These are folders and files for Eclipse's internal use. We don't need to know about those for now. And so we'll just see now how a method works, for example. So I can actually take this piece of code here. I can do this. I can actually do a special advanced procedure, which I'll give you a sneak peek into, called refactoring. So if I just right click here, and I go down to this menu here, refactor, I can use this one here called extract method. If I click this, now what this is actually going to do is it's going to take this statement out, or printing hello world, and it's going to push it into its own method and replace it then with a call to that method. So this is a great way how we can, first of all, reinforce our understanding of how methods are declared, but also we can actually see how they're invoked as well, how the method's actually called, in other words. So it's asking me to give it a name, so I'm going to call the method, say, greeting, for example. And here you can see we've got these access modifiers we were talking about before. You'll recognize private and public earlier on in the course. We'll just leave it for private for now, that's fine. Because we're only calling this method from within this class, it's okay that it's private. It'll still be visible to the method from which it's called, as we'll see. Then here we can see we've got a preview of the signature itself. And the method signature is just a fancy way of saying what the method declaration looks like, with all its combination of modifiers, return types, method name, and input parameters. So now if we click on OK, you'll see that just like that, we've got a new method. So this is how you actually call a method. You just basically use the method name and then the two parentheses there, which matches the method name here and the two parentheses here. And here we can see the method declaration itself. So if we rerun this now, it shouldn't change anything. You just right click again, go down to run as Java application. Yeah, it hasn't changed anything. So you're probably saying, well, what's the point in rerunning it? Well, the point of rerunning it is just to make sure that after we did that so-called refactoring, we're just rerunning it to make sure we didn't break anything. Because in spite of the fact that we didn't actually have any red error marks after we did that, it's still possible that we might have some kind of errors or whatever, depending, of course, on how complex the code refactoring you were doing actually was. So let's quickly demonstrate now how we can actually pass parameters. So if I just go up here, let's supposing I want to pass a parameter here, such that instead of saying hello world, it'll say hello and then the person's name. In order to do that, let's put in a parameter here. So we use the type of the parameter, which is going to be a string, because it's going to hold textual data, so character data, so alphabetical characters, that kind of stuff. And we give the variable a name, which coincidentally will also call name, because that makes sense. We're passing in the name of the person we want to greet. And once we've done that, we can delete this and replace world with the variable that we passed in. If we pass in Matt, it would say hello Matt. If we pass in John, it would say hello John. Now you'll notice over here, we're getting this red squiggly underline again. And the reason is, of course, because we're not actually passing a name now, because we haven't adjusted this method call to take into account that we're now passing a name here. And if we didn't know that, give you another demo of how helpful IDEs can be. If we just click on this X over here, we can see that it's offering us some ways to fix this situation. It's saying we can either add an argument, that means pass a parameter, to match the fact that the method takes a string parameter. That's what we're going to do, by the way. Or alternatively, it's saying, do you know what? You can actually change the method itself to remove parameter. And both of those, if you think about it, would fix the situation. Just press escape quickly just to explain this. If we pass in a parameter here, which is a string, it will match this, which means it would then work. And remove that red X, squiggly underline. And similarly as well, if we removed this parameter here, then we'd have a method which doesn't take any parameters. That would also work, which would again remove this squiggly underline and the red X. So both of those options are perfectly viable. If we go back on again by clicking it, we see there's another option as well, which is to create a completely different method which doesn't take a parameter at all. And at this point, you'd actually have two methods with the same name. One takes a string, one doesn't. That's the concept of overloading I mentioned a few moments ago. So yeah, all viable options which the IDE is offering you, all easy to understand and simple to digest as long as you read actually what it's saying. And you'll notice as well that on the right hand side, where we saw the documentation panel before, which gave us helpful documentation, this time we've actually got a potential preview of code that it could write for us. Now it doesn't know who we actually want to say the greeting to, whether it's Matt or John, so the best it can work out, fancy word for that is infer, the best it can infer, which we usually say, the best it can infer is just to say, well, okay, don't really pass anything past null. We won't go into null and what that is, it's outside the scope of this lesson, but it's one solution. And similarly as well, if you click this one, it's again giving you a preview of what that would look like. Of course, it hasn't fixed the entire code, because even if it did that, and it removed that name parameter, you'd still then get an issue here, where you'd be referencing something that hasn't been passed in. But it's enough to give you an idea of what you might want to do and where the IDE would adapt the code for you. So anyway, we're going to double click here now, and as it promised, it's putting that null placeholder for us, which meant that at least now the code compiles. Now instead we're just going to replace that null value with my name, for example. And if you just press escape afterwards, it loses that box highlight so you can see the code a little bit better. So now if we run the program, and to run as Java application, we'll see that it's doing something else helpful. Because we didn't save that before, you see there's a star there still. Now it's saying, oh, do you want us to save the resources for you as well? Do you want us to save the source file? Yes, I do. I'll even say always save the resources before launching, so it always overwrites. And do OK. And now we can see it's saying hello Matt. So that's an overview of how you can pass parameters into methods. And finally, one of the best features of an IDE, in my opinion, is the ability to actually debug a program. So as programmers, we write program code, and obviously we're writing program code because we're assuming what we're writing is actually going to work. More often than not, it doesn't work. or at least if it doesn't work completely, there might be a few issues with it which we've got to try and fix. And the best way of fixing those is actually to run the program in slow motion. It's the best way I can think about describing it, but this is what you do pretty much when you're debugging a program. It allows you to go through what's known as step over each line of program code as it's being executed. Then along the side of it, you can actually see what's happening to the other areas of your program. Now to show you the idea about debugging that we were talking about before, I could right-click and do run as, that will just run the program, but I can also do debug as, and I can debug the program. Now before you do a debug, or before you launch the debugger, or rather the IDE when it's in debug mode, you need to set a thing called a breakpoint. And that's basically where you want the program to stop, that is to stop running at that specific point, so you can effectively take a look around. So if I go up to here, for example, if I double click in the margin, just to the left of the line numbers, that's how you set a breakpoint. And this means that now, if I right click and do debug as Java application, it'll first of all ask me if I want to switch to perspective. I'll say remember my decision, and yes I do. Go to the debug perspective. Now this is going to change the windows slightly and the panels that we've got. So that now this particular perspective, in other words this arrangement of windows and panels, is geared towards debugging. So in other words, like looking through the code, and actually it's called stepping through the code. See everything that's going on. Just notice the fact that what we've actually got here now is the program is suspended just before it executes this line. So this, when it's put this highlight in here, it's highlighted this line. What that means is I've stopped here just before I execute this line, before I run this particular line or do this method call in this case. And it's effectively saying, well, what do you want me to do? It's not going to do anything unless we do something at this point. What we can do is we can what's known as step into the method. So this is the SayGreeting method, and it's calling this SayGreeting method. So if I go up here to the run menu, we'll see that the first few menu items here are effectively commands that you can do at this point. So I can choose to do step into, which is F5, which will go into that method, or I could do step over, which is F6, which goes over the method. I'll just show what those mean now. So if I click back here, press F5, you'll see that now it's gone inside of this method call. So now it's inside this method here, which we have. You'll also see a few other things now as well. You'll see that in the right-hand pane, we can actually see the variables that are available now. So this method has a name variable which is passed in. If I hover over it here, it actually tells me what that value is Matt, which is really helpful. And you'd only get this in the debug view, by the way, because this is now running code. It's not us programming it, it's the JVM running it now. And you can see over here we've got variable name, it's set to Matt. And then over on the left-hand side, you can actually see what's known as the call stack. And that's basically showing us the sequence of calls that have been called. And it's kind of funny, but it goes from the bottom up. So it's saying basically the first thing that it ran was the main method in the myapp class, which happened to take an array of strings. That corresponds to this one here, the main method in the myapp class, which took an array of strings. Then it got to line 6. You can see here line 6, which is this line here. And now it's at a breakpoint on line 10 in the SayGreeting method, which takes a string. So here we've got the SayGreeting method, which takes a string. And this is line 10, which it stopped at. And you can see line 10 here, line 10 here. It's showing you very accurately what's going on. So like before, when we stepped into the method, if we had a method we wanted to step into the code of, with F5, instead we can press F6 now, which is step over. So when you step over something, it just goes to the next line. So if we do F6 now, you can see it goes to the next line. Now if we do step over again, you can see it jumped out of that method because it finished that method. There's nothing else it needs to do there because it got to the end closing brace, that right-hand curly brace you can see there. But also notice what happened as well. The name variable which we had here before, that's now gone. That's because that's no longer what's known as in scope. In other words, it's not available to us anymore because in this method here, there isn't a variable called name. That was only in that method here, and only specifically for that method at that specific point in time. But now that method's gone. And we can tell that method's gone as well because if we look back over here to the call stack, we no longer have this SayGreeting method here. We no longer have it on the call stack. And in fact now we've progressed from line 6, which it was before, to line 7, which is this one. So finally if we press F6 to step over, at this point there's no more code to run. The application's finished, terminated, and we've finished what's known as our debug session. You can also do various fun things as well when you're in a debugger. For example, you can change the values of things. You can choose to return from methods early. You can choose to throw exceptions. We haven't seen exceptions, but that's a way of being able to say there's an error in the code. You can do things like that. And it really enables you as a programmer to be able to really go in deep to your code and understand at a very deep level how it works. Now, obviously, this program is trivial. It's like the easiest program we could have written, to be honest. And Java programs, they get, of course, increasingly more complex. Although don't worry, because it's always manageable complexity because of the simplicity of the syntax of the language. That's the combination of keywords and symbols and that kind of thing. It's quite easy to get the hang of once you ever play around and practice a bit. But the point is, though, once you take your programming to the next level, you start developing more complex Java programs, that's when you really start to see the power of a debugger. So yeah, debuggers in IDEs, an essential tool to have in any programmer's toolkit. So that should have given you a nice overview of the main moving parts we have in Java programs, and also a sneak peek into what it's like to actually use an IDE to do some Java programming. And as you can see, once you know what you're doing, it's actually not that complex after all. Hey there, Matt Speake here from Java Easily. Now, if you're here, it's probably because you've taken my introductory mini course on Java, which was designed to take absolute beginners to Java and just give them a nice, easygoing and gentle introduction to what it's all about and how to get started. Now, one of the questions I get after the course from students is, how can I take it further? So to answer this, I've created a brand new course, which is the Total Beginners Java Programmer Masterclass, which I'm super excited to tell you all about right now. In this course, you're going to learn core Java comprehensively from the ground up from myself, a professional Java software engineer with over 20 years experience, but, and this is the awesome part, we're going to do this completely live. So it's a series of live Zoom calls that we're going to have together where I'll teach you the core concepts, do live coding to reinforce it all, and you can ask questions either by text-based chat on the call, or by coming onto the call on video, or just audio if you prefer, however you feel most comfortable. It's entirely up to you. But we're going to do this live. You're going to learn Java from top to bottom, and we're going to kick this off from the 1st of March. So, how it works. There'll be 3 calls per week over 4 weeks, so a total of 12 sessions we're going to have together. And we're going to go over every aspect of Java you need to know to be able to program confidently in the language. Java can seem fairly straightforward if you're not that familiar with it, but in fact there's some tricky to grasp concepts in there which you need to have a solid handle on to become successful. So it really does justify a 4-week program. I also want to spread the sessions out so that you have a day or so to take in the concepts introduced before we move on to the next lesson. Now, there are other ways of learning Java. You can go grab a cheap online course from a marketplace, you can watch YouTube tutorials, you can read books, and you can even read Oracle's documentation on their website. All of these are perfectly possible, but you're going to get mixed results with these approaches because, to be frank, there's no substitute for live training where you get your questions answered in real time and get unblocked on the spot with whatever concepts are dragging you down. Plus, there's an accountability side too. If you enroll in a program you pay for, and you've paid for these live sessions, and there's a person, in fact a whole group of people, so the other students too, your fellow classmates, on the other side, and it's not just you with a cheap online course on your own left to your own devices, the chances are you're going to stick to the program and have massive success with it. So this really is an excellent opportunity to nail down your Java knowledge and project you into a whole new career as you embark properly on your journey as a professional Java software engineer. Now, typically, a 4-week live training program would cost around $2,000 online, and that runs to over $7,500 and more for a physical training program, actually on site somewhere. Of course, in the current climate, nobody's doing that, and also, since I want to help as many people as possible, I'm offering this at a much lower price. So the cost for this full 4-week live training program is just $247. So to break that down for you, this means that each live call is effectively around $20, which, for a live call, is practically unheard of and represents massive value for money. Now, maybe you want to take part, but either you don't want to pay the full amount up front, or maybe you don't have the full amount right now. Well, that's no problem too, since we have a payment plan of 3 monthly installments of $97. It's better value to take the one-time purchase price though, to lock in that $20 per session rate, but that's also an option if you need it. Now, maybe you've tried learning Java before and you've just ended up feeling frustrated and kind of given up. Or maybe you're completely new to it all and have just taken my mini course first to get an idea of the basics. That's no problem, because in this program, I'll teach you everything I know about core Java, all my tips and tricks and hints, and over 20 years experience. You'll have it all on tap for a full month during our live sessions together, which I'm looking forward to. And also in a pop-up Facebook group too, which you'll have access to support you along the way. You can also access the recordings after each session too, so even if you miss a session, you can still view the recording, and you'll have lifetime access to those as well. The sessions will take place at 7 PM UK time on Mondays, Wednesdays and Fridays. I'm looking forward to getting started and hope to see you there, so click the link below, enroll, and I shall see you in the class.